Your name when speaking.
I think that's oh no, looking at wrong. No, actually, now, no, now, vegetables gone here. And then you're eating, I get a face into that about. That's a nice thing. Where's the hospital? Did I know? No, I had either of those, one was the sugar, one was the, you know, that was, that's awesome. Wow. That person will lose the light.
We do this like that. Yep.
This is our. I will probably take every for good. The most time, you take that into the I think it is.
Anybody in Idaho or basically Idaho? Good afternoon, everyone. This is BFD. If you're looking for something else, go to a different room.
But please stay.
Okay, so this blue sheet should be circulating around. Not that we meet all that often, but it would be good to be able to get a room when we need one. So please, sign the blue sheets. So advance the next slide. So this is the note well you've probably seen multiple times already. This does actually say that anything you say in the mailing list, on the microphone, in a draft, is a contribution towards the IETF, and you need to understand what that means. Please consult your lawyers. Next slide, please. So in terms of our agenda, we're going to just quickly talk about the status of some lingering things and then go into new materials. The sort of flavor of what we're doing for the next hour or so is talking about Yang and authentication. And the rest of the stuff is mostly lingering things. Next slide. So in terms of things that are in a zombie draft state, the MPLS MIB is basically done at this point. Nobody seems to be super interested in it. We still need to clear out some charter stuff with Alvaro and make sure that we actually get that off the charter at some point. The BFD generic authentication in SHA-1 is also in zombie state, but courtesy of changes to the data tracker, we can now put this in waiting for implementation and leave it that way. What's sort of interesting is generic authentication may get resurrected as part of work we'll be today. So BFD multipoint is a piece of work that we do need to close off. The base multipoint document does have implementation at Alcatel. It also has interest at several other vendors. So we do want to actually push this one through standards. The active tail document is basically still a good idea, but is unlikely to see deployment anytime soonish. Our general idea is that we want to publish these things ideally within the next IETF cycle. So what we're going to be doing is looking for a document shepherd to pick these things up. When we last talked about this at IETF 96, Greg said he might be interested. So we will either talk to Greg and see if he wants to actually carry this through as a shepherd, or look for somebody else that may have time. And what we'll actually be doing is just running this through last calls. We'll be working with Alcatel to make sure that the procedure that's documented there covers what they're actually doing. And this is IETF's chance to say this is a good or bad idea. So the draft that Greg and Jeff Kansura have been working on for basically BFD over multi-chassis, which is basically the same thing as BFDM lag, just in the multi-chassis environment, had been presented in IETF 96. We had good sense of the room at that time that the work is in scope for the working groups, very similar to the BFDM lag stuff. There has been no updates. It's reasonable material. At this point, what we'll be doing is been putting this to adoption on the mailing list, and we'll try to get consensus on that. Greg, please make a comment if you like.
Greg Mirsky, ZT. So we had very interesting comment and good comment from John Messenger at the discussion in Berlin, referencing a new extension to 802.1ax lag specification with a distributed resilient network interface, DRNI. So I looked at the specification. Yes, I agree that that makes MC lag as we know it as a special case. And John suggested consider bringing this work to IEEE. So my thing is that I don't think that IEEE will be interested in using layer 3 protocol to monitor layer 2 object. So if they're interested, they probably will work on extending 1731, for example, or CFM. But what I would like others, member of BFD community to consider is that if there is an interest to generalize for using BFD DRNI or MC lag is something that we would like to address first and see if there will be implementations of DRNI, because it's much more flexible and more powerful, but as a result, it's much more complex.
Okay, so I think there's enough context there that the mailing list is probably the best place to have this discussion. So if you could basically frame this in a set of questions for the working group to discuss on the mailing list, that'll help us advance this. This is not the first time we've run into that sort of headache with IEEE before. You know, when we were doing the BFD and lag in the first place, it's obviously a weird mix between layer 3 and layer 2, and this is just sort of the opposite end of the equation. Next slide. So we're going to go into our presentations. We've chosen to start with BFD Yang, and Rashad will actually be doing that update. And just in case somebody wants to help with minutes, you know, minutes are usually pretty easy here. We are using the Etherpad, and I welcome people helping me to keep the notes.
Can you hear me? Is that good? Yes? Okay, so I'm going to give an update on the BFD Yang data model. Next slide, please. So the changes in draft 05 since draft 03, we basically had two sets of changes. The first ones where we fixed there were compile issues in the 03 version, which were found when we started using new Yang compilers. And also the biggest change really was, as many of the other routing models were doing, we were augmenting network instance. And now we're using the schema mount approach where we define a model, and that model can be mounted in the network instance or at the logical device level. Also now the routing draft became RFC 8022. BFD is now augmenting the base identity control, is defined as a control plane protocol now. And I've added the section on interactions with other Yang modules. Any questions on this slide? What's still not there, BFD over VCCV for pseudo wires. So one thing I've been waiting for is, I think the L2VPN model was going through a fair amount of churn. It seems to be more stable now. There's a new version which was published last week, I think. And so one thing we have to decide, I don't know if it's something we discuss on the alias or among the authors or here, is whether this model should cover BFD VCCV or whether we cover that in a different Yang model. And since day one, we haven't had BFD over MPLS TP, and we've decided that we will not be covering that in this draft. RPCs, up to now, we've said it's not needed. Greg will talk about echo later, where the question of RPCs came up again. Next slide, please.
Actually, pause on the slide. So in terms of urgency, whether you should wait on the VCCV, I think the big question is we're getting pushed to publish Yang models, and I see our AD hiding in the back of the room there. Hi, Oliver. Yep, that's you. So Benoit, I know, has actually been pushing us to get these things published. Do you have any personal sense of, should we just get this thing out and put it in the augmentation in later, because that is an option with Yang, or should we just close this off?
Hello, Rutana, routing AD. Yeah, if it was me, I would push it out. I have no idea, and I'm just saying this because I have no idea what it means waiting for L2 VPN to firm up, how long that's going to take, right? So we might be sitting here for a long time. So if it was me, I would just do it and then augment it until the augmentation later.
Okay. So our job as a working group is to make sure that the structure of the Yang module is good enough so that we can do the augmentation later.
Correct. I mean, right now, the way it is you've got a base model, and then all the BFD for each forwarding type basically augments from there. So we could have a separate module where it be BFD for pseudo wire. I mean, I could even try, just as an experimental thing, how it would work with the current LTPN model to get confidence that it would work up in the future.
Next slide.
So things which, okay, open issues. So there was the discussion on the alias about whether the echo transmit interval was defined properly as being a config parameter, or whether that should be in RPC. So Greg will talk about that later on. To me, that comes down to the question is echo typically used as on-demand or as something which is continuous? So if anybody has any comments on that, now or later when Greg will present, please. And then last, not least, I mean, it's not complicated, but basically spending the time to comply with 6087 bis, which we haven't done yet. And yeah, next one, please. We also got a bunch of comments from Jeff last week, which I think we're on board for most of them. We'll talk about those. We'll have to address those. We'll have to address the open issues on the previous slide. And I think after that, we go to Yang Doctor review.
It takes a month at least to get doctor review.
I'm sorry?
It takes at least a month to get someone from Young Doctor to review.
Questions, concerns?
Okay, nice and straightforward. So Greg will be next to talk about the echo implications. I might have downloaded it. The comment that your eyes are much better than mine. Look at the tiny fonts there.
Yeah, that's what I was thinking.
Okay. Yeah. Okay. So I just put only 2 slides. The first slide is just to recapture what RFC 5880 says about BFD echo. So there are 2 things. First, BFD echo format, the payload of the packet is not determined. So what being sent as BFD echo is open to implementation. So it's a proprietary. Second thing is that it's asymmetric. So asymmetric in a way that BFD peer node, BFD node advertises only based on the standard their desired minimum receive interval. So basically it states, don't send me anything BFD echo more frequently than this. When comparing to asynchronous mode, where it advertises minimum receive and transmit intervals. Okay, and as a result, it's absolutely normal behavior to see that only one of BFD peers is using echo while the other one is not. Because, for example, the other side might just say 0, which should be interpreted as don't send me any echo messages. So another interesting passage or mechanism that described in 5880, and I think that's where our difference in interpretation comes from, is that it suggests that sending BFD echo may be accounted with presence of asynchronous BFD control messages. And if echo messages being sent, so their rate of BFD control messages can be reduced accordingly. And in current BFD Yang model, their model is such that there are two things. So the first thing, the model includes the transmit echo interval as part of the configuration, which is a persistent configuration. And second of all, so from my point of view, echo is not proactive mechanism as asynchronous BFD mode, but on demand. And in my second slide, that's what I want to stress, is a difference, again, in my interpretation, what proactive and what on-demand OEM is. So the proactive is you always have persistent configuration, whereas the on-demand doesn't have persistent configuration. So we had this discussion, we started discussion on a working group list, and then we very soon realized that yes, we have a different interpretation of the mechanism, and some of it is to do with this recommendation in 5880, which says that if you're using echo BFD, then it might reduce need to send control messages, as the messages can be accounted. I'm not sure that on-demand will make it absolutely impossible to do this correction of the rate. I though wonder is that if we reduce the number of messages, that will mean that we reduce the interval and will change the state machine. So interleaving with the echo messages, determination of failure becomes somewhat ambiguous. At least it's not deterministic of which one of the state machine and what has to really constitute their failure, whether it's echo mechanism or asynchronous or composition in both. In my interpretation of 5880, it's unclear.
So I think this is a place to interject, what we see in the real world. So with regard to what do you do about the DFD state machine, especially when it sort of down negotiates it as part of running the echo function, what we tend to see in the field is that echo is there to say that I am taking full control over whether I consider my peer reachable or not, simply by the fact that I'm seeing my traffic loop to me. My payload is my choice, my verification is my choice. So this is taking it a bit out of the state machine because it is now fully under control of the initiator. And the only thing DFD is requesting is that the session not exceed a given packet per second rate. So it is to some extent the choice of the implementation as to what it wants to do there. What I think this does towards the Yang module, which is the original point of this conversation, configuration hasn't changed. We have what the user had put in as its intent for the async session and also for the echo session. Operationally, we're always going to show what the active state is. Whether we negotiated our timers down as part of running the protocol, or if we're still running at the rate that was originally configured. What might be absent from the model that maybe you could offer some suggestions on is when we've done this down negotiation, we can see that in terms of the settings in the async session, whether or not the echo function has any sort of representation of the operational state. And I don't think that's there right now. I can't tell that echo is actually in progress. I can't tell what it happens to think about things. And the problem is this is left explicitly out of the spec as a, I'm not going to talk about this, which makes it a little hard to put it into a standardized Yang module. I think what we might be able to expose is echo function is active. You know, it is working or not. If a implementation wants to augment the DFD module to say something about what it's injecting, that's great, but I think that's probably in the space of a vendor augmentation at the moment.
Right, but again, stepping back, original discussion started that the transmit interval, whether it's part of persistent configuration or it's a part of RPC. And even if we extend it further, is that initiating echo session is it a part of configuration as enable, disable, or it's a part of RPC?
So I think in terms of the management of the things, the Yang module that we're talking about, it's an inherent property of the end user. So I would not expect the DFD implementation to prod the Yang module to initiate a echo activity is its way of interacting with DFD. Now this would be something the internal software would do. The place where you'd want to expose this in the Yang module is if you expect the end user to use the management plane to actually initiate something. So in the case of something like SBFD, which is really on demand, that might make sense. And SBFD functions are not really covered strongly inside of the Yang module at this point. We know those would probably be something we want to augment at a later point. So I think my observation would be this sort of on-demand behavior triggered by the management plane is probably out of scope for what we're trying to do for this first round of things. But as we talk about SBFD, maybe it's time to revisit that.
Yeah, actually, as you bring up SBFD, because there is a certain dependency SBFD to the IGP protocol.
It's dependent on other state. That's IGP is one way to do it.
One way of really advertising discriminators, or another way is just to do RPC query.
Or simply by provisioning.
Okay, but again, I just wanted to bring up this question of echo VFD to the discussion, because to see whether we think that echo transmit interval is part of persistent configuration or of something else.
And unfortunately, I think it's out of scope, but it is definitely a good place for a vendor augmentation.
Okay, then, so you will consider is that to being not in a base model. Okay, that I would agree.
Okay. Well, thanks for bringing up the topic. Okay, so I think we're moving on to our next slide. So we're entering the portion of our session where we're talking about DFD authentication and things that'll be being used for. Our first presentation from that will be Sonal. You can adjust the microphone however you want.
So today I'll be talking about an enhanced.
Or if you want to, if you take it out.
You can either take it down or lower the stand. Yeah, the stand can go down too.
So today I'll be talking about an enhancement to RFC 5880. So the reasons we have this enhancement is 5880 states that the authentication is done on the entire packet. If we have a keyed MD5 or keyed SHA1 or the and the other thing that it states is that the sequence number is exposed in every DFD packet. So there is an enhancement we're making to the security of the packet here that states we actually don't have to authenticate the whole packet because it's expensive when packets come at line rate. It's expensive to decode the authentication on the entire packet. And we can authenticate parts of the packet, and the part of the packet that we want to authenticate is the sequence number. So we want to protect that, and that's what this draft talks about. And also the authentication is not on the whole packet. It is just on the sequence number and how we can hide the sequence number from all intruders. So that's the reason for this enhancement. So, can you get the next slide? So the problem is that sequence numbers increase monotonically. So it becomes very predictable what the next sequence number is going to be. So when that happens, it's easy for the man in the middle to bring down the BFD session or take control of the BFD session. So in order to avoid this, we've come up with a proposal. Okay, so the high-level algorithm is that you take your sequence number, which is increasing, and you push it through a hash algorithm, which is a symmetric 32-bit hash algorithm. When you hash the sequence number in the hash algorithm with a shared key, the sequence number is now hidden from anyone who tries to intercept the packet. So instead of placing the sequence number in the sequence number field of the packet, you place the hashed value in the sequence number of the packet. So that's the high-level solution. Okay, so basically you provision a hash algorithm and a shared key securely on the sender and the receiver. And this has to be a symmetric hash. For the reason is that the receiver has to perform the reverse hash on what the sender did. So the sender encodes the sequence number using the shared key and the hash, and the receiver decodes the sequence number using the reverse hash and the shared key. The expected sequence number will match the decoded value, and the receiver now knows what the expected sequence number will be. If the sequence numbers match up using the reverse hash, then you know that the packet is good. Otherwise, you know that the packet is a bad packet. So this is just an example. This is just an example on all the sequence numbers that would have been provisioned. So on top we have what RFC 5880 uses. So it uses increasing sequence numbers. And when you have a hash with a shared key, these are just random numbers I chose just to show that the array below is basically the sequence number when computed in a hash with a shared key. So in 5880, you have the hash on the whole packet, which when you have to decode the hash, it's expensive because it's on the whole packet. But here, this is just on a 32-bit value that is hidden from all attacks. Now, it provides a level of security because intruders will not be able to detect the sequence number and hence won't be able to bring down the BFD session. So the there are two things being achieved here. You're not hashing the whole packet, you're hashing only the sequence number, and you're also protecting the sequence number from being exposed from all intruders. And that's basically it.
So we're going to get into a broader discussion after the next presentation about the optimizing BFD draft. We'll be doing something slightly out of order of the agenda. And what should hopefully become apparent from the update is this mechanism is intended to address one of the problems that we had when we were sending unauthenticated BFD packets in the clear. We want to run authentication less. How do we run authentication less without actually making ourselves vulnerable during that time to man in the middles. So please feel free to ask questions now or ask combined questions after the next presentation.
So actually, I have a comment. This is, when you say without authentication here, this is assuming the null authentication TLD of the optimizing draft?
No, this is independent of that.
Okay, so you guys really intend to have this as independent, side by side?
Side by side with the other draft. The other draft can also make use of this, but this can run independently.
And what's sort of worth pointing out is that this mechanism can be used outside of BFD. Basically one of the generic problems IETF has is if you want to make sure that you have some piece of high volume data, BFD being an excellent example of that, where you can't afford to do an actual hardcore encryption action like SHA-1, SHA-2, etc. That this mechanism for data that has a short lifespan may actually be a good way to provide medium grade security. Well, thank you. Let's proceed to the optimizing presentation. We'll do performance at the end. Makes sense to sort of get these two things together.
All right, so this is an update to the draft that we have been discussing in BFT for some time. As Jeff mentioned, one of the action items that we had taken from the last presentation was the question of how to deal with unauthenticated packets that we had proposed that we don't need to essentially authenticate every packet, and we can let the remaining packets go in clear. So I'll come to that and how Sonal's draft kind of fits into this. So just the other update is, of course, the consideration, the INA consideration for a null auth. I believe it's a reserved field right now. So we are asking for an addition for null auth in that. Next slide, please. So in the proposal that we had made, we had suggested that only a BFE packet that is actually going to make a state change should be authenticated or needs to be authenticated, that the remaining packets that do not indicate any state change can go in the clear. But that brought up the issue of what happens if someone actually takes over a session at that point, seeing the packets going clear, and tries to bring the session down. So the action was, one of the recommendations was for us to say, every so often we'll go and authenticate one of those packets just to make sure that the session hasn't been taken over. That's only as good as we do it enough, frequently enough that somebody can't get in the middle. Next slide, please. This is where the suggestion of taking what is already, what Sonal presented in terms of using the meticulous sequence number and saying that if we were to hide or munch the sequence number, then we would actually be able to prevent the man-in-the-middle attack in the cases where the packet is going in the clear. Next slide. So pretty much, as I said, the draft has been stable except to deal with this particular action item that we had of how to deal with sequence numbers. And we believe at this point, of course, that the document is ready for last call. Questions? Greg Nursky, ZT. So my question is that in the draft, so you indicate that one of the possible modes when their session is up is to use authentication with some periodic timer trigger. Sorry, say that again? To use authentication as a timer trigger. So basically, ever so often to send the packet with authentication.
That was one of the options we had.
And that is because authenticating each and every packet is computationally challenging.
Right.
So when I think about hardware-based DFD implementation,
Mhm.
so I think that then the idea would be is that verification of authentication is offloaded from their forwarding engine.
Okay.
And that raises the question is when we say that the received packet with the authentication being validated, when we complete authentication verification or when we just verify some portion of the packet.
It is when the packet is completely authenticated.
Okay, but that affects the state machine because I can envision that the rate of sending packets is quite aggressive.
Yeah, but when you're doing a state change, you're not under obligation.
No. But you indicated that it's possible to use authentication when the state is up.
Right.
Okay,
And remember, it's only occasionally, every 1 second.
Right, but occasionally, every so often, so you sending the packet, and then let's assume that after this packet being shipped for authentication verification, we lose 2 packets in a row.
Okay.
So which will cause drop to down, because if authentication takes more than time than receiving 2 packets, no. Why?
Yeah, so say you're not able to authenticate in time the
Yes.
first packet, right?
Yes.
But you receive 2 packets after
No,
that.
I don't receive. I drop them. I lost them.
So if I could, I think what Greg is suggesting that in a hardware-based implementation, if you're trying to keep the authentication, the hardcore authentication in line on the line card, the action of doing that may burn enough resources that it causes packet drops.
No, but no, it's not that scenario. I imagine that it's like authentication is a bump in the wire. So authentication verification being shipped to control plane. And I have a high rate of packets, so let's say running at 3.3 millisecond. And let's assume the control plane is so busy it cannot get to process these packets in the next 7 milliseconds. But so happens that the next 2 BFD packets that's supposed to be processed by hardware got lost. So what I have 1 packet that's still waiting processing and 2 packets being lost. So I'm out of my dead interval.
True. Yeah. So in that particular scenario, you're left with no option but to bring the session down. Yes.
Okay. So you think that it doesn't have to somehow change their validation scheme so that at least this packet that's being accepted and sent for authentication validation gets counted as a valid packet?
Well, one possible implementation, and I don't know, is that before you bring the session down, if you already have a packet that you know is waiting authentication completion, can you wait on that?
Yeah, but if single authenticated packet fails to be validated, does that bring the session down? Because again, it's not in a document.
Okay. Ian, did you have a comment? Okay. To the mic.
I hesitate because it's been a while since I've read this, but so I'm working from memory, right, rather than the document. But the authentication is essentially a separate process. You just keep receiving the packets, and if they look right, you assume that the session is still up. At some point, you get around to validating whether or not the authentication is correct, and you go, oh, damn, there's a problem that happened a little while ago. Let's take it down. Or let's set off an alarm if that's the only trigger that is associated with the detection of an authentication problem. And you just keep going. I don't understand Greg, what you're, and maybe I've just misunderstood you. You're not blocking on anything. If you happen to lose 2 and you're counting for 3, then you keep going. So you don't get 3.
Yeah. My understanding that if you're using authentication, that you encrypt the whole packet, the whole BFD message.
So only putting a checksum on the package, you're not actually encrypting it unless you change something.
No, Ian, I think what Greg is referring to our previous option, he's not referring to the suggested changes that we are making. In our previous option, we had recommended that every so often, every 1 second, as a suggestion, we would encrypt a packet. And in that case, what Greg is saying is that the timer will expire, and therefore the system will have no option but to bring the session down. And I accept that argument.
So Les Ginsberg, I'm just curious, this discussion assumes that it's a practical problem that authentication cannot be completed within the session hold time. Is that a realistic problem? Does anybody know?
So it's not specifically that problem. It's doing that same thing every 3.3 milliseconds.
No, so, but.
A single operation, if single operation is too long,
So
that's a
that's why there's a proposal to say, let's not do that on every packet, but every nth packet. And now you're saying, gee, what happens if I lose the other n packets? And I'm asking, is that a practical problem?
Yes. I just want to say that usually you might have thousands of BFD sessions, so multiplied by.
So to the argument that, okay, sorry, I should have latched on to what he's saying. It's not just that, so authentication is not only for that packet, it's taking more than 3.3 milliseconds. It's actually taking 9.9 milliseconds for the authentication to succeed before, for you to be able to say, oh, I lost 3 packets. Now, if you're not able to authenticate the packet in 9.9 milliseconds, then yes, you're totally out of luck. You probably shouldn't even be doing authentication to begin with.
No, but again,
You need faster hardware.
Right,
in
right.
other words.
Yeah, the thing is that we can talk about multiple concurrent BFD sessions, which is usually the case. Okay?
True, but the same argument, meaning if your hardware is not capable of authenticating every nth packet, then you probably shouldn't try to deploy.
But again, the premise of this work is that yes, we realize that authentication is expensive, and we want to somehow do it periodically, not for every packet. Because if that's not a problem, if performance is not a problem, then why we do it periodically? Why we not authenticate each and every packet?
Okay,
Right.
we know for a fact that authenticating every packet at 3.3 milliseconds is a problem.
Right.
What we don't know is that authenticating every nth packet is a problem. We won't be proposing this if we could not do any authentication at all at wire speed.
I can assure you is that if we have a problem authenticating every packet and we start authenticating every 1 packet in 1,000, then with 1,000 sessions, it still will be a problem.
So this to me it's a scale problem. Forget about authentication. For a particular hardware, I can support n sessions. That might be 10, that might be 100, that might be 1,000. So now we're increasing the cost of supporting a session. That clearly affects your scale. So maybe the hardware that could support 1,000 unauthenticated sessions can only support 100 authenticated sessions. You get it.
Yeah, so
It's not free.
It's not obviously free, but the thing is that we are changing the flow of the packet in a system. Because if we authenticate each and every packet, then the processing of the packets and validation is sequential.
So
If we are shipping authentication somewhere else, offloading, then we are changing that sequential. Okay? Because
So there's a comment on Jabber from Shesh specifically on this point. Let him get his words in too. So in hardware implementations, the sequence number option will be better fit compared to a scenario where authentication is not in line. In any case, authentication of the offloaded frame is not related to the subsequent frames. So more than one person is making the point that even if you're changing the path through which the authentication stuff flows, doing the fast stuff in line, doing the expensive stuff potentially on a different engine, the fundamental property that you care about is, can you actually do this work in a timely fashion for the scale that you're looking at? And as you start, this is a multi-dimensional problem, as BFD always is. If you increase the numbers on one thing, you change what you scale on the other ones. So if you could support authenticating 1 out of n, that's great. But as Greg points out, if you make n big enough, you'll eventually run into enough authentications happening potentially at the same time to cause you some level of headache. The one thing that BFD tries to give us to help with this situation a little bit is we're expected to apply jitter. I think one place that we might be able to be a little bit better descriptive in our text about the periodic authentication is some way to maybe make sure that jitter applies to that type of behavior, so we don't end up self-synchronizing.
Sounds good. So that's something certainly we can add to the draft. Okay. All right, so we'll make those changes and resubmit the draft for consideration for last call.
Mahesh, quick question, which probably been asked before. Has there been any experimentation in terms of what kind of we can scale X times better with this as opposed to what we're doing?
So not specifically with this form of authentication. The difference between no authentication and full authentication was, I believe, 1 in 5. So the numbers dropped to 1/5 if you were to do full authentication.
So in terms of the actions that come out of this, I think we're probably slightly premature on last call. The procedures I think are well understood. It's just a matter of how do we fold in the procedures from Sonal's draft to cover the situations we knew were problems. Some of that includes how do we actually do the initial sequence number discovery in order to be able to do the hash of the sequence numbers for the cases where we're applying that mechanism. So I don't think we're ready for last call, but certainly after integration we probably are. What this does mean is that we would, as part of this work, also need to pick up Sonal's draft as basically a dependent draft, and therefore make it a working group draft. Is that what you're looking for?
Yes, we are.
Okay, I assume so, but you always have to ask. So what we'll be doing as part of the post-meeting stuff is putting out an adoption call for this to make sure that the working group agrees, and hopefully we'll probably set it for about 2 weeks after IETF is complete, and the two of you can sort of work together on making sure that your Sonal's draft is actually covering procedures that are sort of generic, and your draft is covering how to actually integrate those procedures to solve a specific problem.
Right.
Can the optimizing draft go to last call without the sequence number of obfuscation going to last call?
Not if you're actually going to use it.
Right. So it will probably get held up in ISC or whatever last call, waiting for Sonal's draft to reach a similar state.
Yeah, so in terms of publication, it does mean that both drafts must advance together because they have a normative dependency on each other.
Yes.
But more importantly, we can't last call optimizing until we actually have the procedure making use of this mechanism nailed down.
Right. That too. All right. Go to the last draft.
Okay. Yep. So we're on our last presentation. This is an update on the BFD performance mechanism.
All right. So this is an individual draft, and the questions raised in the last meeting were related to several questions actually: how the delay measurement was going to take place, where was the values going to be stored, receiver, sender, how the two are going to get correlated. So that, and the other was what impact, if any, it would have on the optimized auth draft that we just discussed. Next slide, please. So with all those considerations and considering that it really wasn't trying to solve a whole lot of issue that people already didn't know, we decided to drop the delay measurement calculation, but keep the sequence number of the ability to count and see if there were any BFT packets getting dropped in a BFT session, and using that as a mechanism to figure out whether the BFT session was stable. Is still very much there, and we see quality and ability to use that to figure out or predict whether there's going to be a network event that might ultimately bring the BFT session down. Next slide, please. So we believe having dropped that and made it a very simple draft, all about counting sequence numbers and making sure whether that is a good enough indication of the state of the BFT and of the network, that we believe that it has some value to be considered as a work profile.
Any questions or comments on the update BFT performance? This does clear out one of the security concerns that was there for the feature, conveniently using the same mechanism.
Also, I'm curious, who's read the draft?
All right.
Thanks.
Okay, so we'll take the adoption request to the mailing list. That said, we have 4 minutes left in the session. Unless there's any ad hoc business, we are concluded.
Thank you.
If you have not signed the blue sheets, please do so.